I thought tonight it might be interesting to speak a bit about causality and causation, since I mentioned that in passing in the previous video, especially as a problem. Um, and again, the sort of theme that keeps recurring in this video series is the whole thing that we have to treat certain sorts of claims, the evidence and proof claims, um, with caution, and we can lump into that into that thing probably for round about the same sort of reason. Causal claims, especially, need to be treated with an abundance of caution. Um, and so it might be useful just to look into some of the background of why that might be. Um, and really the beginning of it, and I'm really actually beginning at the end here, but essentially the beginning of it is that logic, predicate logic, basically is made up of a series of truth claims or statements that have truth values assigned to them, plus logical connectives. So if one thinks of truth claims, you can think of something like there's a camera in front of me and there's a cat on the bed. Now, in this case, both of these claims are true, and we can use logical connectives to connect these kinds of statements together. So, for example, we can use the logical connective and, so there is a camera in front of me and there's a cat on the bed is also true. And then we can use negation. So we can say, well, there's a camera in front of me and there's not a cat on the bed is false by our setup. So it's pretty basic and straightforward. And you get a whole bunch of logical connectives like that, like or statements and if statements, and biconditionals, if and only if. But essentially, one of the main big insights of 19th century theorizing about logic in general. Now, I'm not sure if C.S. Peirce was the first one to really note this. I think there might have been somebody else before, and he certainly wasn't the last one to note this. But essentially, what was discovered was that you can reduce all of the other logical connectives down to NAND or NOR statements, to NAND or NOR connectives. So essentially, you don't need to use or and or if or any of these connectives. You can just use NAND or NOR, and in fact, that fact is exploited by computers, where essentially your predicates are essentially your ones and zeros of computers. So one is true, zero is false, and computers only use NAND gates essentially. So you construct all of logic. Anything that you can say logically, you can construct with just those ones and zeros, and the NAND gates to connect them up in all sorts of different ways. So that's essentially where logic takes you to. But importantly, cause is not one of these logical connectives. There's no logical connective that says cause. There's the if statement, which is if A then B, which is essentially saying like saying that you're not going to have a case where you have thing A happening, like say you have a camera in front of you, and at the same time there's no cat on the bed. So now you're saying if there's a camera in front of me, there's going to be a cat on the bed, and of course that statement already sort of has this hint of causality sort of like embedded in it, and the whole time based implication of the if statement is something that I think I'll discuss in a future video, because it's quite important, the relationship of time to truth claims. But essentially, the if statement is just an and statement like that, where you're saying it is not the case that there's a camera in front of me and not a cat on the bed. That's if there's a camera in front of me, there's a cat on the bed. So it basically becomes an if statement. But we have to distinguish that from a causality statement. And if we go back to Aristotle, made some distinctions between different ways of between different sorts of causal statements. The first kind is the material cause, which essentially just deals with the matter involved. And then there's the formal cause, where we might say that the formal cause of rain falling is the water molecules in the air combining to form water droplets and then being too heavy and falling out of the clouds or whatever. That's a formal description of what's happening. And here we're talking about like material form. So if we're talking about the material cause of rain, it's the water falling out of the sky. So we have the material cause and the formal cause. And then we can have the efficient cause. Now, if you're talking about rain, the efficient cause of rain is a little bit trickier, because the efficient cause is like almost like asking who is making the rain. So if we might say Thor is making it rain, then we're saying that Thor is the efficient cause of rain. And then we might go one step further and say the ultimate cause of rain is for Freya to make the plants grow or whatever. I'm not so hot on my mythology, but I think I'm mixing up different cultures here. But whatever, one can get the idea. And this is often where causality is very, very always on the edge of flowing into religious concepts and things like that, because as soon as you start thinking about efficient and ultimate causes, it becomes very problematic to state those in scientific terms without starting to think of sort of intentions behind entities. And that slips in very, very easily into one's thinking about science when one starts thinking about causality. But essentially, just thinking about that distinction between logical claims and causal claims, which and the main issue here is that a causal claim in general isn't well defined. We might say, oh well, the clouds rolling in caused it to start raining. Well, what kind of cause do we actually mean here? What is the sort of the logical statement, the logical status of that sort of causal claim? And we can make sense of it. It's just that because it's not well defined as a sort of a logical claim in general, it invites us to shift gear very easily from one sort of causal claim to another sort of causal claim without noticing it. And that's really the big risk with these sorts of things. The major logical fallacy that involves causation is post hoc ergo propter hoc. Post hoc ergo propter hoc, which means just because something happens after something else doesn't mean that it was caused by that first thing. And we have to keep that distinction really, really clear, because lots of things happen after other things without there being a causal connection, a well-defined causal connection between the two events. And in fact, Hume made this very important distinction, and famously, Kant, on reading Hume, made the remark that Hume awoke him from his dogmatic slumbers. So causal claims have this tendency to push one into dogmatic positions, because once you accept a causal claim like that, it's very easy to arrange reality in your mind as sort of fitting those sort of causal categories. And so dogmatism is one of the consequences of being incautious with causal claims, really. So one of the first starts, one of the first ways to really get into a good, healthy way of thinking about science is to, I wouldn't say immediately dismiss causal claims, but to dismiss them as being as being of any strict logical value in that kind of sense. Theories don't really actually say anything necessarily about causality. Causality is always this kind of a loose notion that kind of floats about there, and is always a source of a lot of problems in this sort of thinking. So yeah, I thought I'd just cover that in a bit more detail, and also just introduce where the lines of logic is a bit more clearly, because that'll be important going forward. These problems with causality crop up again and again, and that'll be a recurring theme. But I should note that this series is not really meant to be negative about science and that sort of thing. So it's just negative about a certain sort of interpretation of science. But I do have a positive thesis about science and truth claims in general. I'm not negative about the utility of truth claims. Just incautious truth claims is where I have an issue with. So I'll leave it there for tonight, and yeah, have a good one.